Hey students, lesson 1-2, points, lines, and plane. Notice on your blue sheet that there are lots of vocabs in this one. So a lot of important things here, kind of pay attention to the details there. Go ahead and do the review here and you can check back with your answer. You'll want to pause now. All right. So the important thing here is that we learn how to identify points, lines, and plane, and actually how to label them and all those things. So some important concepts here that we're going to go over. Some of these things are undefined. We just kind of know what they are, and some will be defined using other definitions. So we'll start here with this is a point, just a little dot, and this is a line, and this chart actually shows you the ways you can name them and also some options for naming them. Like in the second one, it says the name is line AB, and notice there's a little arrow on top to show that it's a line that continues forever. You can also just use a script letter L like they have there to name this line. So we could say line L, or we can use the two letters AB. All right. This next thing, when it's a shape like this, a two-dimensional shape with points inside, that's a plane. Where there are no arrows on the end, just points on the end, that's a segment, a line segment, or just a segment. All right, and if you have an arrow pointing just one way with one end point, that's a ray. All right, one more here. Notice that C is the end point of two different rays, ray CA and ray CB, and they form a line. When that happens, those are called opposite rays. So notice that definition there. They need to share a common endpoint and create a line to be known as opposite rays. All right. Go ahead and try this. See if you can get it right, and you can check back with your answers. So here's your answers. One thing I don't like about it, and you should take a note here, when it says it matches up this segment BF with the intersection of planes ABF and CGF, and that segment right here, BF, if it's the intersection of two planes, just because the planes look like they end at the edges of this rectangular prism, they really don't. Planes have no dimensions. For two dimensions, they go on forever and ever. So the intersection is actually going to be line BF. You need to make a note of that. That's important. All right. Some important postulates, and just so you know for now, we'll talk about this more later, but a postulate is something that's assumed to be true. We're not going to try and prove it. It's just like your basic knowledge that you start with without defining it. So postulate 1.1 says through any two points like that, there's exactly one line. You can only draw one line through there. It's distinct. If two distinct lines intersect, then they intersect in exactly one point. Now, one thing you have to know about that is that the two distinct lines are on one plane for that to happen. If two distinct planes intersect, they intersect in exactly one line. And through any three non-collinear points, there is exactly one plane. Non-collinear means like this. So one line can't go through there, but that would be enough to represent one plane. Okay, go ahead and try this and you can check back with your answers. How'd you do? You should have used those postulates that we just wrote to do number 20, 22, 23, and 24. The other things are undefined terms. All right, so problem one, what are the names of the segments in the figure below? What are the names of the rays in the figure? Which of the rays are opposite rays? All right, so A, the names of the segments, there's a few of them. We can name segment MN, and a segment has no arrows on top, so it will look like that. Segment MP and segment MP. B, the names of the rays. There's more rays than there are segments because the ray has an endpoint and a direction. So we can start by doing MN, that's a ray. MP is a different ray. Actually, those two represent because they have the same direction and the same endpoint. So we really don't need to name those two different ways, but it's two different ways to name the same ray. We could go the other way then and do PN or PM. And we also have our opposite rays are NM and they have to share an endpoint, so NP. Those are opposite rays. All right. Part C says, oh, that was part C. All right, so go ahead, you try that. I see my numbers are mixed up in yours, so on your paper you're going to go back to problem 1 now. It says, what are two other ways to name a line AB? And two other ways to name line AB are line AF and line BF. What are two ways to name plane Q? To name a plane you need 3 letters. 2 isn't enough, there's an infinite number of planes through 2 points, but you could do like plane CAD or plane CED. A couple different ways to do that. What are the names of 3 collinear points? Collinear means that they're all on the same line. So that can be E, A, and D, or maybe F, A, and B. What are the names of 4 coplanar points? That means all on the same plane. That could be like C, E, A, and B. They're all on the same plane. All right, I'll let you try these. Check back. Okay, so each surface of a box represents a part of a plane. What is the intersection of plane AEH and plane EGH? 2 planes intersect in one line, and that's one of the postulates. I think it was postulate 1-3. So our line, we can use the letters E and H to represent. All right, so go ahead and try the next one. All right, problem 4. Which plane contains points J, M, and L? And that would be the top plane right there. And then it says which plane contains points L, P, and Q? And that would be this one over here. All right. Go ahead and try this last problem. Okay, I'd like you to do the lesson check, and we'll check your answers tomorrow to see if you understand. That's it. See you tomorrow.